And now we have two pieces left, 5 ways to get students thinking about microgravity experiment design and website navigation. So let's figure this out. So here's where we are right now in the context of where the students are at. They understand classic experiment design and the need to try to hold the variables constant and change one of interest. They understand that the independent variable, the one of interest that you want to change, typically comes from the essential question driving the experiment. They understand the nature of a control experiment, so something unknown compared to something known. They understand that the essential question flavor for everything we're doing here with SSEP is what is the role of gravity in something under study. They understand that gravity plays a role in virtually everything, and for instance, biology behaves differently with a different gravity. They understand, maybe depending on how deep you want to go into the curriculum, they understand that the astronauts, that you can't carry an experiment far enough from Earth where gravity is so low that doing an experiment there compared to the surface of the Earth as the control will allow you to do this experiment, because even the International Space Station, which is 400 kilometers above the surface of the Earth, is really close to the Earth. So you can't take it far from the Earth to make this experiment work, but they may understand, if you go into details, that the astronauts are not weightless, that they weigh almost the same as on the surface of the Earth because of the mountain thing. They understand that the reason the astronauts are weightless is because they are in free fall, because you went through the elevator thing and the ping pong ball thing. And they understand that the way to do this experiment is to trick it by putting it in a continuously freely falling environment where it seems as if gravity doesn't exist. And if you run the same experiment on the ground, in gravity, when the flight experiment comes down, you put them side by side and you look at the behavioral differences in what you're studying to understand the role of gravity. They understand why the mini lab is so small, but it's very capable. They understand that the sophistication of the fluids and solids define the sophistication of the experiment. They understand why 75% of the experiments are biological in nature, because you probably want to activate the experiment once in a weightless environment and deactivate it before it goes back into Earth gravity. They understand examples, the two examples that we talked about with regard to lower grade level and upper grade level. And now they say, okay, I'm ready to figure out what kind of microgravity experiment I want to do. And now they're puzzled. How do I even start doing that? Well, there are 5 ways that I can name right off the bat that help you understand how you can get students to figure out what kind of microgravity experiment they want to do. The first step, reinforcing this over and over again, before they even think about experiments, like what Allison was suggesting as, hey, what about this one? Because I bet you students are going to come up with, hey, let's work with the astronauts. Before they start designing their science experiments, they have to know the mini lab operations page backwards and forwards, as do you, to know what is doable and what is not doable. Just like my use of the spectrometer back on chapter 1 on Mauna Kea. I need to know what it can deliver. Now, one way to do it, the first way of 5, is to look around your world and say, gee, that's really cool. I wonder what the role of gravity is on that. And because I've read the Minilab operations page, I know that will work in the Minilab. So they can look around their world and come up with something. Now, I'll give you 2 examples. There was a young lady who is, I believe, in 5th grade, and she went down into her basement one day, and it was a damp basement, and she saw moss growing on an inside surface and wanted to know what the role of gravity was on the life cycle of moss. There was a high school junior who had biology the year before, and she loved the planaria worm regeneration lab. So she said, gee, I wonder what the role of gravity is on planaria worm regeneration. That's where that experiment came from. That was an example I gave you earlier. So you can look around your world. A second way of 5 is you can do research online to see what kind of microgravity experiments have already been done and get ideas there. A third way you can do it is you can go to the document library and download the microgravity science background document, which provides an overview of 9 separate science disciplines appropriate for microgravity research and why, say like crystal growth. And there's an accompanying case studies document that provides examples in each of those 9 science disciplines. So that's a third way that they can get ideas. A fourth way they can get ideas is they can download the microgravity experiment samples document from the document library, which lists hundreds and hundreds of biologicals that are available, hundreds and hundreds of fluids and solids that are typically used in microgravity experiments, so that they can get an idea from looking at that very comprehensive list. And the fifth way that they can do it, which is really powerful, is they can go to the website and read a 1-paragraph summary of over 400 microgravity experiments that have already been done via SSEP in the mini labs. And if they want to do the experiment over again, they can. Or if they want to do an experiment with a twist, they can. They can zero in on looking at experiments at the 5th and 6th grade level, because all of the grade levels are listed with the experiments. They can look across different disciplines, science disciplines. So there's a very large library. Now, here's the deal. We are not expecting your students to add to the human book of knowledge and doing something seminal in science research. The other thing that's really important here is that the deliverable to you is a proposal written against a proposal guide, grade level appropriate, with embedded citations and a bibliography of primary references. We are going to give you exemplar proposals of selected flight experiments so you as teachers can see what a winning proposal looks like, but you cannot and must not share the proposals with the students. And there are no proposals on the website. And the reason for that is the only thing they get is the proposal guide with the template for a proposal. And you cannot get a proposal from a 1-paragraph summary of an experiment. In that proposal, like the Hillsborough team, they have to propose an experiment and then justify why it is a good microgravity experiment with embedded citations and a bibliography. They have to provide procedures for how the experiment is going to be done in the mini lab, how the ground control is going to be done, and when the flight experiment comes down, what analysis they're going to do to see what the role of gravity is, to see if they've answered the essential question that drove the entire experiment. So does everybody